This podcast sometimes uses strong language, and it may cover topics that require viewer discretion. Also, it's a podcast. It's not a primary source of information. If you'd like to follow along visually with the show, or read any of the papers we talk about yourself, you can find all of those links and more at ridiculousresearchreview.com. So today's Scientist Find comes to you from Unilad headline. Scientists find the moon is drifting away from Earth, and it's having a huge impact on time. The underlying research there is from a study by the University of Wisconsin-Madison that shows that the moon is drifting slowly away from us, which is affecting the Earth's rotation, which means that sometime in the distant future, we may reach a 25-hour day.
Yeah, but that's got to be...
And that's apparently a huge impact.
We have to be talking about the scale of millions of years here, right?
Absolutely.
Yeah, Unilad needs to understand what the word huge means.
Hey, man.
Like, it's not going to be a problem for me.
Yeah.
Neat. All
Okay,
right.
that's all I got.
How do we introduce ourselves? How do we do this?
I don't know. Let's do this. Okay. Welcome to what we're currently calling the Ridiculous Research Review, where we look at some weird science and talk about it. My name is James Lynch. I have a PhD in mechanical engineering. I study the physics of insect flight and robotics. And I read a whole bunch of weird biology and robotics papers that kind of inspired this whole project.
I liked it better when you called yourself Dr. PhD James Lynch.
Yes.
Yeah.
It's Dr. James Lynch, PhD.
Dr. James Lynch, PhD. I actually recently added another set of letters to that. I just can't do it anymore.
What do you mean? Wait.
What do you mean you can't do it?
Hold up. What do you mean you added another?
Yeah, I'm now a licensed professional engineer in the state of California, so I'm actually Dr. James Lynch, PhD, PE.
Right.
I got 5
Okay,
letters
yeah.
after my name now, and it's too many.
Fantastic.
It's too much.
Can your accolades become longer than your actual name? Can that be your new goal?
Well, 5 is the
Like-
yeah. I need 5 more. Let's see if
You need to become a lawyer. That'll get you 3.
lawyer would get me some. I could get some other certifications. Anyway, who the hell are y'all?
Now, I am Edie Churchill. I am a nonprofit finance and operations professional. I did a bunch of theater once.
Great.
You did a bunch of theater. Perfect. Cool. I'm Pat Brennan. I am a technical director for theater and a professor. I specialize in the esoteric, strange, and entertaining, I would say, which is sort of what I bring to this podcast.
God, you sound like a carnival guy.
It's not far off.
Anyway, we got a fun one today.
Uh-oh.
This is one that I saw as a video first, so you all are going to see it as a video first.
Hey, I hate that. Hey, I hate that.
Yep.
Not a big fan of that.
I've actually got 3 videos for you to kick it off.
Oh, these visuals could be so many different things. I'm really concerned.
Yeah. We're going to start with a video, and I'm just going to play it, and I ask you, it's 20 seconds long. Just go ahead and just watch the whole thing.
No!
Oh no! Bad!
No!
Anybody want to describe what you see?
Oh.
No!
Okay, so
I don't want to be seeing this. How about that?
there appears to be a spider skewered on a needle. That needle is attached to some form of robotic lifting arm. There is what appears to be maybe some mushed up raspberry on a table. Foam. It's foam. It's labeled foam. Also, the needle that is skewering the spider is labeled as spider gripper. Which, like, I guess technically, if you skewer something, you're gripping it, I guess. but somehow it is managing to make the spider's legs open and close and pick up the foam that is on the table. But the spider can't possibly be alive with a needle literally through its fucking skull.
Uh-huh.
No.
Next video.
Oh, you've got more.
Similar to the first.
It doesn't need to be.
Okay, but they didn't change anything. It's still just a spider picking stuff up. They made a grabby claw out of a dead fucking spider.
Last one.
Oh, good. You can pick up a spider with your spider.
You
What
can
are you
use
talking
you
about?
can use a spider to
Oh.
pick up another spider, folks. You
Hey
can
guys,
do
they
it.
made this game way less horrifying. It's called Monkeys in a Barrel. It's way easier than using dead spiders and I guess pumping air into them. Like when it says pressure, how are they pressurizing these spiders? I hate that sentence. I hate that sentence came out of my mouth.
You want to know how they're pressurizing the spiders, Edie?
No, not really, but you're going to tell us.
I sure am. So real quick, just give me a
Stop
quick
playing
sense.
the video. You got to stop playing the video.
I love playing the video. I love playing the video, especially this one where they're using a dead spider to pick up a dead spider. This is
You
some.
know
This is
that
gonna haunt me.
you know that I have to put an arachnophobia at the beginning warning at the beginning of this episode.
Oh,
yeah?
absolutely.
Okay,
There's a lot
cool.
of spider talk in this one, folks.
Okay.
All right, so why do you think, like, real quick, just you see this, what do you think?
Get me the hell out of here. I open a door. I see folks in lab coats operating the pneumatic dead spider arm, and I close the door and I pretend I never saw it, and I move on with my life. It's like the tool like your dad uses to like grab the keys from back behind the couch, like one of those little dino
Yes,
arm
exactly.
things, except he's got jammed the daddy long legs on the end of it.
Yeah, what if
Yeah.
that was a spider? Wouldn't that be better?
No.
So, welcome to science. This is Necrobotics, Biotic Materials as Ready-to-Use Actuators, published in Advanced
Ready
Science.
to use. Sorry.
Published in Advanced Science a couple of years ago. The lead author is Tae-Fei Yap, and the head researcher is Daniel Preston. They're both researchers at Rice University. And in their introduction, they summarize very, very clearly what it is they're out to do. In this work, we employ the intact body of an animate biological creature, a dead spider, as a ready-to-use biotic actuator in the first step toward an area of research we call necrobotics.
Yeah, no.
What do we think?
In every fantasy game or fantasy book I've read or played or any of that, the necromancers are always kicked out of the university for their unnatural ways.
Yeah, now you get to see firsthand why that is. Again, you go into Daniel Preston's lab and he's got that on the desk and you're like, actually, Daniel, we need to put you in the basement.
Hey.
Or maybe it's time for you to leave the campus.
Yeah.
Hey, here's the thing, though, and I want you to think about this: is that they use the word biotic, and it's very important to understand the definition of biotic here. Okay, so biotic is the use of any biologically created material,
Organic material, right?
Yeah, it's organic materials. Wood, leather, lots of different materials that we use all the time, like the.
Hey, if they had made a grabby claw out of wood, we wouldn't be having this conversation.
I've got a shop filled with wood. Apparently, these folks have a shop filled with spider corpses ready to go.
Here's the thing. What's the difference? Maybe it's your mind that's not broad enough. Okay?
I don't
Incorrect.
think that's the
False.
problem. Wrong.
Maybe we need to be thinking about, like, well, what if it's not just the material? What if we use the anatomy?
Nope. When I die, let my bones turn to dust. Don't you dare steal them and turn them into a robot.
Look, so the proposed applications of this are micromanipulation, because you know, tiny spider, you can use it to.
Pick up other tiny dead spiders.
It reduces waste because it's compostable.
What are you saying?
I mean, those like rubber and plastic those rubber and plastic grippers, they don't decompose. That's just garbage when it breaks.
Okay, so hold on. So you're James. You're like, here's a pro. It's compostable. Let me give you a con. Presumably, you need a spider farm to grow spiders to feed your ever-growing need for spider corpses.
We'll get to that. We'll get to that.
Oh, good. Christ. Oh, God, did they farm spider corpses? Okay, keep going.
They're ethically sourced spider corpses. Thank you very much.
Well, they do say that one of the problems that there are no clear, and this is a quote from the discussion, there are no clear guidelines on ethical sourcing and euthanasia of spiders, which is clearly just like that's just a systems problem, you know. That's just a logistics problem. Like,
this seems to be, we haven't done a lot of these yet. This does seem to be an ongoing problem in the papers that you bring us. These scientists are like, where can we get more dead bugs?
All right, we're gonna go through some of the paper figures. We're gonna go through some of the paper figures, talk about the process here. So, figure 1
Oh, God.
is the process by which you create a spider gripper. First, you
Okay, so they did euthanize the spider. What a clever euphemism for murder.
Yeah, so euthanizing the spider requires just putting it in a refrigerator because they don't like the cold.
Also, a continuing plot point in these papers.
You just stick them in the fridge.
So I do just want to go through this photo really quickly because I don't know that we've fully explained it because so step A is euthanize spider. You stick the spider in the freezer. We talked about that. Step B, fabrication. We've got a needle going into the upper back, thorax, skull.
Main body part of the spider.
The bit that isn't the spider ass.
Yes. Not the prosoma, not the abdomen.
We put a hypodermic needle, I'm assuming of some kind.
Yep, into the body cavity.
Into the spider.
Yep.
And then that looks like a tube of super glue to me.
It is 100% just super glue.
Right.
Why? Hey, if it ain't fixed, why broke?
Which they do refer to this super glue as a self-sealing mechanism.
Yeah,
which, I guess, sorta.
Some of the work of writing a science paper is sales, and this is one of those cases where you glued it and then you realized it sealed it, and you say, "Oh, it's a self-sealing mechanism."
Hey, this one I gotta tell you, this whole image, this is a tough sell. You can't take this to any Target in America and sell this.
No, they are gluing a needle to a spider and calling it fabrication.
But hey,
okay, so hold on. We're not through it. So it's step A, euthanize spider. Step B, fabrication. Step C, necrobiotic gripper. Then we have a real photo of a spider on the end of a needle with its legs in and out.
Yeah.
And I guess
no further explanation, just simply euthanize spider, fabrication, profit.
Check it out.
That is what this figure is. Yeah. Now you have a necrobotic gripper. Aren't you happy? Aren't you excited?
Don't you wish your life wasn't like this?
Sure.
Yeah. So I will say that. So what they describe is that the way that the whole spider gripper works, is by leveraging this really interesting fact about spiders. They have these really long legs, and part of the problem is that out of the tips of the legs is not a lot of space. So they've evolved this really cool trick where they only have flexing muscles, meaning while we have what they call antagonistic muscles, like on your bicep, you have a bicep which pulls your arm in, and your tricep which pulls your arm out. In spider legs, there's actually only the muscles that pull in. In order to stretch their legs out, they actually use muscles in their prosoma. I think is what it's called. Is the body, the main body part where all the legs are attached.
What I've been lovingly referring to as the skull.
It's it's part. The head is in there. The eyes are in there. It squeezes that part of the body, and then the hemolymph, which is the name of their blood, and it does other things as well, gets pushed out into the legs, which causes them to inflate and actually stretch out.
Okay.
So spiders stretch out their legs by pushing fluid out into their legs.
Spiders
And they're
have
like
hydraulic
little-
legs.
Yes.
That's actually really cool.
It's really freaking cool.
I kind of dig that.
They have hydraulic legs to extend them, and then they have little muscles that that close the joints back up. So it allows them to have only like these little strings of muscle way out at the tips of their legs, but still have dexterity in those legs, because they just kind of push their blood around and they are able to have these hydraulic motions. It's very cool. It is also the reason why a dead spider curls its legs up. It's because the springy muscles, when they're no longer activated and there's no more pressure inside the body, pull the legs in. And that's why like a spider will like have its legs curled up and it's on its back, because it's pushed itself over. And so what they have done, and what I watched a short video of them that discussing this discovery. And
Discovery.
It does seem that they were like, well, if they're hydraulic, I wonder what would happen if we stuck a needle into their back and pushed on the needle. And it worked.
Jesus Christ. So, like, it's just some bored grad student was sitting in there, was just like, what would happen if I jammed this needle in a spider corpse? And he was like, oh, look, the legs move?
Yeah, and it worked the first time. And they were like, this is so cool. We should write a paper about it.
I'm pretty sure
And-
bored grad students are a plague on this nation.
Sometimes they make discoveries. Sometimes,
I still fully don't understand why I need this.
well, let's find out how strong it is.
Oh,
We have to figure out, like, well, in order to know,
maybe that's what it is. Maybe it's super strong.
maybe it's super strong.
Do you know how much worse it is if it is?
So, Figure 2 shows a universal testing machine, which is a fancy little movement stage, and a balance. And what they're trying to figure out is how heavy a thing can this spider grip. And essentially what they show this sort of series of photos that start with the pressure applied, so the spider gripper is open. They go down to this little red ball, and then they take out the pressure so it grips the ball, and then they move the spider gripper up, and they measure the force that it exerts on the ball to find out, okay, how strong are these little spider legs? What could we possibly lift with this? Okay.
Okay.
They have a very nice little graph right here where they're looking at the force that it applies. Low force at the beginning while the legs grab onto the ball. It reaches a peak and then falls off as the legs slip away from the object.
What are the different color codings happening here?
That is how are you applying extra force? How much pressure are you applying to the spider? What you see is that when there's very little pressure, basically the spider is passive. Like it's just those passive muscles in the leg that's holding on to the object. That's when you get the most force. But as you apply, if you apply higher forces, higher amounts of pressure, then the legs are not going to grip as hard.
Because pressure causes the legs to expand, to kick out.
Yeah, exactly. Right. The pressure causes the legs to expand.
Another way to say this would be, how inflated is your spider?
How inflated is your spider? That's exactly right.
I wish it wasn't.
I want to give some context here, because what they say is that the absolute highest gripping force that they found here was approximately 35 millinewtons. I think it's hard for people to understand what newtons are. Newtons are like they're a unit that makes a lot of sense when you're doing a whole bunch of physics problems in high school, but in the real world, you almost never use newtons. So I did convert that. I'm going to give you something in a different metric. A paperclip is roughly 1 gram.
Okay.
Okay? 1 gram translates to roughly 9 millinewtons. This thing is lifting 0.35 millinewtons, so it could not pick up a paperclip.
It could barely pick up a speck of dust.
It can pick up a little piece of foam. It can pick up another spider,
Yeah, we saw that.
but not a lot of other stuff. Not a lot of other stuff. It is not very strong.
You made a horrifying grippy claw, and it's useless. Got it. Okay.
And it's not very strong. The reason it's not very strong is that the thing that is holding on to whatever you're gripping
He's dead.
it is dead muscle.
Yeah. No,
It
we
is
got
dead
that.
muscle.
Didn't take scientists to crack that case.
No, because you've made a gripper out of something that's dead.
Why is there another video?
There is another video because one of the other benefits of this design is that because it's just, you could have very controlled pressure levels using a machine, or you could just have a handheld little syringe, so you can hold it yourself. In this video, a person holding a syringe opens up the spider gripper, picks up a piece of foam, and moves it from one point to another.
So much more efficient than using the hands that I evolved to do that is to use the spider corpse.
No, it's actually better if you had to move a piece of foam. If you had to touch it with your own fingers, it might get contaminated. Here, instead, you can use a hypodermic needle and a dead
On
spider.
a decomposing corpse.
And you can move whatever you want that's under about a gram.
Uh-huh.
Yeah. So obviously, some other things you might be thinking about like, oh, well, one benefit that you'd get from it being a biological, biotic material, is that spiders have evolved for camouflage, in their environments. So, like, what if you needed to, for example,
Lift a gram in secret?
lift a gram, but in secret? In the supplement to this paper, figure S4, they show exactly what that would look like. There's the spider gripper superimposed over a leaf. It is a little bit hard to see.
I guess kind of, but thankfully they've highlighted.
They have highlighted it.
If you couldn't tell from the orange hypodermic needle, they've circled the spider corpse on the end of it quite helpfully.
But hey, you can go pick up a leaf with a spider corpse.
I see that this is happening in that first image, but it took me a long time to see that it was happening because I was very much distracted by the second image you're showing us here, James.
Yeah, I am showing you both at once, which, the second one is another problem that you might have seen. Another problem you might have seen is that when things die, there is no longer any life energy to prevent the onset of entropy and decay. AKA stuff starts to decompose. And it turns out that when you're using the internal fluids of the spider as your working fluid of your actuator, it's important that you don't lose any of that fluid to, evaporation. So they did foresee that this would be a problem, so they ran a test to see if you coat a spider in a thin layer of beeswax and then leave it out for 10 days, it actually loses a lot less mass to evaporation than the uncoated spider would. The uncoated spider lost 10 whole milligrams of
spider juice.
Of mass of spider juice.
Of internal spider juice.
Yeah. So a future version of this study would be a beeswax coated spider gripper that could last. I didn't include this in the figures I showed earlier, but they found that you can open and close this about 700 times before the legs start to not work anymore.
Fall off, you mean?
The angles get a little wonky is what they measured. They were like, oh, it doesn't really go back into place at a certain point.
Every photo in this project is completely unhinged and insane, James, where like they realize that they could inflate a spider like this, and someone is desperately trying to find a use for it. They're like, it must be good for something. The beeswax solution is so funny because they're like, now our spider grabby arm does have a downside.
And that's the part I'm really struggling with this, because I this entire time I've been trying to think of like, all right, if I get serious for a second, what could they possibly be testing to try and what is this working towards? And the only answer I can come up with is some asshole stuck a needle in a spider and thought it was cool.
Yeah. Well, so I'll give you my hypothesis here. And I don't have enough information to validate that this is true.
Okay.
But I do know from a press release from Rice that Daniel J. Preston got an NSF Early Career Research Grant. He is a early career professor. He is somebody who is probably still pre-tenure.
Okay.
And it's a really precarious place to be. Because you've put all this work in, all this investment. You have the job, but you need to make sure that you... basically, by the time you get tenure, you need a community of people that vouch for you as an expert in the field, and you need to be a leader in the field.
So he's got something to prove.
He's got something to prove.
Beyond that spiders are good grabby claws.
Yes. And the main thing, the thing that really comes out to me is like that line that I read at the beginning where they talk about they introduced the word necrobotics.
Right.
Is they say that this is the first step toward an area of research we call necrobotics. That's drawing a line in the sand. That's saying...
It sure is. I would like to not cross it.
They are saying this is the first paper of a whole new field called necrobotics that's going to be associated with bio-inspired robotics and another field that's called biohybrid robotics.
Okay.
Biohybrid might come up in another one because biohybrid robots are also pretty wild.
Again, I'm like vaguely familiar with a lot of the Warhammer lore, and I am certain that this is the field of study that leads to my skull being used as a hubcap.
Exactly. That's like I am not. If that's what they're trying to sell, right? Like if that's the end goal here, is they're trying to sell that there is this new field of robotics where we can
we're using dead
organic materials in robotics. I think it is too short a leap from that idea to someone going to Walmart and being checked out by a corpse. Like, it is way too easy for exploitation, and I really, really think that these people should be kicked out of their university for their unnatural ways. No, that I'm joking. I do not wish ill on Daniel or Tefei.
Faye is the way she's referred to in the press releases.
I wish no ill on them, and but man, you got a lot more to do to win me over so far.
Yeah, the thing that I get from this is like sometimes you just gotta you gotta put your neck out there and you make a proposal. It's like, hey, now this is where we should go, and I think it's totally valid to be like, no, I don't think this is where we should go.
Because I do other agree. Places we should look.
Because like if you are successful, then where do we leave? What are we like? Are we gonna breed a whole bunch of spiders Are we gonna be breeding spiders just to euthanize them and make them into robots? You know, like, is that the world we want to live in?
Well, it's similar to the idea that it's a short leap from here to like using dead humans in some way as robotically, right? And I know I'm making a slippery slope argument, but
well, it is. But like there's a more direct one, which is like, you know, it's like if it's okay to do this with the spiders, and let's say that we did find a use for the spider claw arm. What if we need bigger ones? Can we use octopuses? Is that okay? Like that. There's your slippery slope right there.
Yeah. How about birds? Like, what if we can hijack the brain of birds? Like, is that okay?
I don't want to hijack any of these things.
Organic drones? No, thank you.
Yeah, like this is these are the types of conversations that are important to have in terms of like ethics. I think most people don't really have a problem with you like killing and messing with the body of a spider. But it's because we have less empathy for things that look less like us.
So I know that a lot of this paper seems to be focused on necrobotics, and I'm sure that's why you have mostly brought it here, James. But do you know if does this paper have any research or relation to the there was a paper I saw going around on like the soft grippy arms that I think were being researched for like space projects, where it was like a similar idea with like a claw arm, but like the claws were like a soft inflatable essentially.
Oh, totally. Totally. Yeah. That's a really like that's a deep and well-developed area of research is soft robotic grippers is absolutely that, and this is informed by that.
This is informed by that, but this is not trying to necessarily link their work back into that. They're not saying this would be they're not implying Dead Spider would be an improvement on soft grippy hand.
They do say that at least it's decomposable. They do say that like it's not. It's actually.
You keep giving that as their one pro, and it's so very funny. They're like, yes, listen, look, does it have a face? Yes, of course it has a face. Is it a spider? Yeah, it's a spider, but it's decomposable.
They do say that it is easier to fabricate because you saw it's two steps.
Yep,
it is.
It's two steps. It's just 2 steps, and that it's decomposable.
Pour one out once again for the poor grad students of the freak scientists who showed up to work that day, and they were like, jam all these spider corpses full of needles, please.
It's the beginning of a Frankenstein movie where they're putting electrical impulses into the brain of an animal and watching it twitch. It's literally that.
I mean, yeah.
Yeah. Man, I am going to bring some biohybrid robots because, like, robotic stuff, like one that I won't bring, but I'll tell you about. And this one's wild because I found a hobbyist kit to do this.
No.
Yeah. They found that cockroaches have those very long antennae in the front.
No, thank you.
And they use those to sense where the wall is. So they like to run against walls. So what they found is that the signals that those antennas send to the cockroach are really simple little pulses of electricity. So what do? You glue a battery and a little bit of circuitry onto the back of a cockroach, and then you snip its antenna and attach electrodes to it, and then you have a little Bluetooth connection, and you can drive it with a remote control.
I'm in hell. What are you?
You can.
I hate it.
You can, and I found a hobbyist kit. It's like $100, and
So you're telling me there are hobbyists that are driving RC cockroaches?
RC cockroaches.
FBI, I got a cool tip for you. Anyone who buys that hobbyist kit, right to the top of your list.
Yeah,
right to the
straight to jail.
That is a real thing that you can really buy, and it is not that expensive.
Anybody who clicks yes please puts that in their Amazon cart. Why don't you go ahead and see what else they're working on at home? I'd love to know what their other hobbyist kits are.
Yeah.
So this is a thing. I mean, trying to think about like when you talk about bioinspiration a lot. Like, well, what if you use cells? Like,
well, no, that's the other thing. Is like it does ask the big ethical question of like where do you draw the line when it comes to organic materials? Because like obviously we mostly live in wood construction homes. Like
we wear leather boots.
We're using all of these organic materials already. What is it about this that makes that feel real icky and not okay.
Yeah.
Okay, so where are we putting this one, Edie?
Oh.
Yeah. So let's start with impact.
Okay. For
One.
this
Let's
study
start with
itself,
impact.
for this study
But
itself,
this study
One.
itself.
maybe
One.
Yeah,
a
this is
1.5 because
I-
it could have future impact. Maybe.
I can't imagine a world where a spider grabber is going to.
Yeah, no, you're right. A 1. I'm conflating too much with the idea that maybe there's maybe maybe something in this necrobotics idea, but the spider grabber ain't going nowhere, folks.
Because what, like, Edie, think back. What did we see the spider grabber do? Right?
Nothing.
It moved computer parts, right?
It can lift another dead spider.
And to that I say, like, why is there, like, the only reason I'm lifting dead spiders is if you're growing dead spiders to make more of these things, right? That's
Right.
the only reason you have that many dead spiders in your house is a problem.
Yeah.
If you're putting spiders into my electrical components, please stop doing that. Like, what technology are you repairing, right? Like, one time I found cockroaches living inside of my coffee pot, and I threw the whole thing away. So if
Correct.
you are intentionally
Yeah, wow.
putting dead spiders into anything that I own, the next trip it will take us to the curb.
Correct. Fair. Okay. Yeah. So 1.
One.
Impact
So
1.
this is a 1.
Yep.
That's a 1.
Yep.
Okay.
And here we go. Scientists are freak scale on a 1 to 5. Edie, maybe I'm controversial on this, so I think that this study is a 4, right? Because this is
Yes.
freaky stuff that you're doing, right?
Correct.
Like what you were asking your grad students to do by putting needles, like our hypothetical grad students, like by needling up all these spiders.
Yes.
Boy, the college should look at what you're having your class do.
Should really take a close look at that. Yeah.
However, I think the bigger crime here is actually the real purpose of this is to bring into common parlance, I would say, the word necrobotics, which is, I think, their real goal here, which is that this team, as you've mentioned before, looked at Frankenstein and said, yes, but what if
Yeah.
us?
But what if us? Which I still think is 4. I'm gonna give this a solid 4 because I think it can get freakier, my dude.
You think it can? But even just the concept of the field of necrobotics, right? They want to have their names stamped on the annals of history as
Yep.
the
I just want to say
pioneers.
we got to leave ourselves room because there is a world I can imagine in which this is not something trying to kick off necrobotics, but something trying to kick off necrophilobotics. And
No.
that is
Okay.
where you get into 5 territory, my friend.
Okay. All right. I will yield. This is a 4, but I will gently say it's a high 4.
A high 4. Yeah,
It's a high
that feels
4.
fair.
A high 4 feels right. Oh wait, they wrote more. There are more necrobotics. No, I think they have a review paper about necrobotics. I'm gonna go read it later. And some other cool stuff. There's a lot of cool research coming out of that lab actually.